Hi, my name is Deepak. Today I'm going to introduce that the software interrupts in microcontrollers. Software interrupts are a powerful tool for managing events and multitasking in embedded systems. They are implemented by the processor itself, providing a structured way to handle unexpected occurrences in a system. Interrupt service routines ISRS for specialized functions. ISRS are small programs designed to handle specific interest events, ensuring a rapid response. Second, efficient handling. They are called automatically when an interrupt occurs, ensuring the immediate execution of necessary actions. Third one, controlled execution. ISRS are executed with interrupts disabled, preventing other inputs from interrupting the current ISR. Fourth, quick return. ISRS must be short and efficient to avoid delaying critical operations. So this is the interrupt vector table. Address interrupt vector 0 into 00, reset vector 0 into 04, NMI vector 0 into 08, hard fault vector 0 into 0C, memory management fault vector 0 into 10, bus fault vector 0 into 14, usage fault vector 0 into 18, SV call vector and 0 into 1C, debug monitor vector. So after studying the table, here it is enabling and disabling interrupts. How to enable and disable. Enabling interrupts. Interrupts are typically enabled globally using a specific register. Second, disabling the interrupts. Disabling interrupt prevent the processor from responding to interrupt request. Third one, specific interrupts. Individual interrupts can be enabled or disabled using dedicated control bits. Interrupt priorities and masking. Priority levels. Interrupts are assigned priorities with higher priority interrupts taking precedence over lower ones. Second one, interrupt masking. Interrupt masking allows specific interrupts to be ignored, preventing them from interrupting the processor. Third one, priority based handling. The processor prioritizes interrupts handling the highest priority on first. Handling multiple interrupts. Interrupt occurrence. The processor identifies the source of the interrupt based on the interrupt vector table. Second one, interrupt handling. The corresponding ISR is executed to handle the specific interrupt event. It is third one, return to execution. The processor returns to its previous execution state after completing the ISR. Now, common interrupt source in microcontrollers. First of all, in diagram you can see there are transistors, and these two are push buttons, and at the above LEDs, then plastic film capacitors, resistors, PCB mount electrolytic capacitor, inductor or coil, ceramic capacitor, USB port, piezo buzzer, and integrated circuit in between. So common interrupt sources in microcontrollers. Timers can generate interrupts at regular intervals, enabling periodic tasks like sampling data or controlling actuators. Second one, in the external interrupts. External interrupts are triggered by external events like button presses, sensor signals, or communication protocols. Third one, analog to digital converters, ADCs. Analog to digital converters, ADCs, can generate interrupts when conversions are complete, allowing for efficient data execution. What are the advantages and applications of software interrupts? Timely response. SWIs enable quick and efficient handling of critical events, ensuring real-time responsiveness. Multitasking capability. SWIs allow the microcontroller to handle multiple tasks simultaneously, improving system efficiency. Third one, enhanced flexibility. SWIs provide a structured and flexible mechanism for managing events, adapting to different system requirements. Fourth one, wide applications. SWIs are widely used in embedded systems, from industrial automation to consumer electronics. Now here is the example. When the processor executes on SWI instruction, it sets the program counter PC to offset 0 into 8 in the vector table. The instruction also forces the processor mode to SVC, which allows an operating system routine to be called in privileged mode. Each SWI instruction has an associated SWI member, which is used to represent a particular function call or feature. Now here example. Here we have a bigger example of an SWI called with SWI number 0 into 1, 2, 3, 4, 5, 6 used by ARM toolkits. As a debugging SWI, typically the SWI instruction is executed in user mode. So two things are given here, pre and post. Pre, the CPS are equal to NZC VQIFT user. PC program counter is given 0 into 00008 and then 3 times 0. LR equal to 0 into 003 and 5 times F. 1R is equal to R14. R0 equal to 0 into 1 2. Then 0 into 00008 000 SWI 0 into 1 2 3 4 5 6. Now this was the post. Now this was pre, and now I will show you post. CPSR equal to NZC VQIFT SVC SPSR, which is NZC VQIFT user. Program counter is equal to 0 into 0 and 8. LR equal to 4 times 0 8 004. R is equal to 0 into 1 2 here. Since SWI instructions are used to call operating system routines, you need some form of parameter passing. This is achieved using registers. In the example, register RO is used to pass the parameter 0 into 1 2 as shown in pre. The return values are also passed back via registers. Code called the SWI handler is required to process the SWI call. The handler obtains the SWI number using the address of the executed instruction, which is calculated from the link register LR. The SWI number is determined by SWI underscore number is equal to less than SWI instruction and not 0 into FF 0000 and 00. Here the SWI instruction is the actual 32-bit SWI instruction executed by the processor. Thank you.